All right, guys. So we just have example 4 to look at. I liked example 4 so much that when I was looking through what I wanted to have you guys do, I apparently picked it as one of your problems to do as well. I just noticed that this morning. So the last problem in your packet is also this exact same problem. So yeah, that's how much I like this one. So one of the suggestions, I feel like I didn't make enough, but I'll make it right now. When you hit these calculator active problems, whether it's particle motion like these ones are, or even if it's like an E9 problem, a smart starting place is to just pop open Desmos and put the function in. Whatever it is they have given you, put that function in. That way you don't need to keep typing the same thing over and over again. So that's kind of where I'm going to start here. I'm going to pop open Desmos. You should too. And we'll say that the v of x is not open to the right page. There we go. -2 plus the quantity x squared plus 3x plus 3x to the 6/5 power, sure, minus t cubed. All right. This way, whatever I have to do, if I have to find v prime of that number, I can find v prime of that number. If I have to integrate that function, I can just do integral of and use the letters v of x. So I think that's probably the best advice I could give you just at the very start. If when you're in that calculator active section, the first 2 questions, pop open Desmos, get your function or functions in right off the bat. And now we can go back and look at the question that we have to answer, which is one of these two. Maybe it's this one. Yeah, there it is. Okay. So letter A says find all of the values of t in the interval between 2 and 4 for which the speed of the particle is 2. Not velocity, but speed. So what are we looking for there when we want the speed to be 2? Absolute value of the velocity. So what could the velocity be to answer this question? 2 and -2. So I'm just going to quickly jump to Desmos, and I'm going to put in 2 lines. I hate that it does that. Y equals 2, which is probably 1 point of this 2-point answer, and y equals -2, which is probably the second point. We want to be strictly between 2 and 4, so that's I can point on my screen. That doesn't help you, but hopefully you can visualize. You can see the 2 and the 4 there. We have 2 numbers to write down as our answers. And there we go. So yeah. So we're going to write down 3.128 and 3.473. 3.128. Yeah. Now, buried inside of the general directions for an FRQ, everything that you're doing should be shown. So again, we can kind of pop up the scoring guide and see whether this is important or not, but it's probably not the worst idea to just, show where you got those things from. Why did I get those? V of t equals 2 or V of t equals -2. Not the only way to show it, but I think if you've kind of thrown all that there, you probably have all your bases covered. But we'll take a look at the scoring guide right before we finish up. Questions on that one? So speed's an important one to remember. It doesn't necessarily match anything else we do in other context problems. It's its own sort of thing, but you've got to remember, check both signs of the numbers, positive and negative. All right. Letter B says, write an expression involving an integral that gives the position of s of t, and then use that expression to find the position of the particle at time t equals 5. So what they are asking us to do here is basically write an accumulation function. Our accumulation function it's not a pure accumulation function because we do need to have a starting value here. But this comes from the idea that whenever we're integrating something, the integral tells us the change. So if we add the starting value to that change, that gives us our new value. So the idea here is we want to do the s of 0, or sorry, the s of x, or I guess the s of t, there we go, third time's a charm on that one, that's what they want, is the s of 0 plus the integral from 0 to t, and I want to write v of x dx here, and I am correct with my letters on that one, because we are not plugging this in over here. We are plugging this in up there. So we need to use a separate dummy variable inside of our integral. If t is used, then we'll use x. Okay. So a couple things that should, kind of always match when we're doing this. Wherever your initial position is, we should be writing that should match your lower limit. And then if you are writing an accumulation function and you're giving it a name like s of t, then that should be at the top of your integral. And integrating velocity, which would be, did they give us labels? They didn't, but meters per second, miles per hour, tells you how much the change in the miles are given the hours. So that should all make sense. I'm trying to think if that is good enough for that. I think that's a pretty much good enough answer. You may write this. A lot of people might write this instead, 10 plus instead of the f's of 0. I honestly just wrote s of 0 there to emphasize the connection between the number you put here and the limit you put at the bottom. So both of those are good answers. They told you that s of 0 is equal to 10. And then we have to use that anyway, so we're going to have to put the 10 in our next step. So the s of 5 equals 10 plus the integral from 0 to 5 of v of x dx, which is literally, after that equal sign is exactly what we're going to type in Desmos next. All right, so we need to do 10 plus. Int int gets us the integral. We want to go from 0 to 5 of v of x dx. So the position is negative 9.207. Keep pressing the wrong one. And I think I've done everything that they've asked me there. I wrote an expression involving an integral to find position, and then I used it. This doesn't change. This is always how you're going to do it. If they give you velocity, integrating will find you the change in distance. So starting value plus the integral will give you exact position. Questions on that one? All right. Letter C, find all the times in the interval at which the particle changes direction. Justify your answer. So what am I looking for the particle to change direction? Well, I am looking for relative extrema. Relative extrema of what? Yeah, in this case, they called it s of t, but yeah, s of t or x of t, whatever the position function is, right? So we need to know relative extrema of s of t, but we have v of t. So where are the relative extrema of s of t? When v of t changes sign. So that happens when v of t is 0 or undefined, right? So we're either looking for v of t to be 0 or undefined. You are looking at a graph in Desmos, so you know that v of t, I hate that it does that. You know that v of t is not undefined, so you're good enough to write v of t equals 0 there. And then, of course, you also have to have the sign change there. Looks like that happens at these two spots, 0.536 and 3.318. 0.536 and 3. Yeah. Okay. I just wanted to scroll those down before I lost them from my brain. There we go. Am I in the right spot? No. T equals 0.536. T equals 3.318. And then what I would just do, I'd probably just next to each one say that V of t changes signs. With particle motion, that's enough. If the velocity changes signs, it turns around. I don't need to say that velocity is the derivative of acceleration, or velocity is the derivative of position. I shouldn't say that it's the derivative of acceleration. I don't need to say that it's any derivative, because with particle motion, all the things have their own meaning. So velocity changing signs is enough. So V of t changes from, at 0.536, it was positive to negative. Yes? Is someone looking at the graph? Oh, all right. And at the other one, it went back. So, yep. Letter D. Is the speed of the particle increasing or decreasing at time t equals 4? Give a reason for your answer. This is another one with particle motion that you need to know what they're looking for there. How do I know if a speed is increasing or decreasing? Right, the signs of velocity and acceleration match. So I need to explicitly say what the V of 4 is, and explicitly say what the A of 4 is and how I found it. What am I going to type in to get the A of 4? V prime of 4, exactly. So this is what my setup should look like. And then this takes a half a second over in Desmos, because maybe I'll get rid of this stuff since I'm getting messy over here. But all I need to do is type in the V of 4 and the V prime of 4. I'm going to try. Third time, there we go. Definitely easier on a regular keyboard. So we got our numbers there, negative 11.476 and negative 22.296. Let's do it this way. There we go. I don't have to ask you. Take a picture of it. All righty. So we've got negative 11.476, negative 22.296. Cool. And then just a simple sentence, the speed is increasing because acceleration and velocity have the same signs. Sure. Means the same thing. Yep, because acceleration have the same signs. You're right. Thank you. And then I think I added this one to the question. I don't think it was originally there, but I just like to keep asking average questions so we make sure we do the right thing. What is the average velocity of the particle on the interval from time between 0 and 5? Average rate of change or average value? Average value, right? So we just need to do an integral from 0 to 5. Put a 1/5 out in front of it, because last time I checked, 5 minus 0 was 0. Does not matter which letter we use, X or T. And just right back to Desmos. Too bad I deleted my integral. Hey, I didn't. Look at that. So we got 1/5. And that's negative 3.841. Boom. And that is the average velocity. All right, let's take a quick look at the scoring guide from this. It's a blank tab. That's what I need. Google 2013 AB FRQ scoring guide. Oop. There. It worked. All I needed to type was SC. That was question 2, right? Yeah. 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 Okay. Yeah, so actually, it looks like if you only put one answer there, you would not have gotten any points for part A. So the scoring guide says considers that the absolute value of velocity equals 2. We wrote that v of t equaled 2 or negative 2. So we considered that. We're good. And we had our answers, and those match our answers. Letter B, again, same deal. We have S of t written out there. Like I said, I changed it to 10. I had S of 0 to just really emphasize that point that whatever your function is being taken at the beginning should match the x value or the t value down at the bottom of your integral. I think you'd be fine having S of 0 there, especially since it was defined in the problem. S of 0 and 10 are information that they told you are the same thing. And then you just use it in your next one. They did the same thing that I did with the t's and the x's. So, yep. I think, yep. Letter C, we consider that v of t equals 0. So when you see this in a scoring guide, these are generally the things that you just need to write. Like, how do they decide that you've considered this? You've written this thing down and you've gotten the full credit for that. We found the two numbers. We talked about the sign changing. Newer scoring guides never have a 2 here. It's always point by point. There's never like an all or nothing sort of thing. The way this one was scored back in 2013, if you didn't have the 2 correct answers, you got 0 points. But they don't do that anymore. And then, of course, again, velocity and acceleration have the same sign. They have the less than zeros there, but I think that's for a modeled answer. But you can see they did the things that I said. V of 4, A of 4 equals V prime of 4. So those are the things that they are looking for. You do need to show them where that A of 4 came from. All right. So with that being said,